together to come up with some fundamental particles. So first, what we're going to do is we're going to do what's called a baryon, which adds any three quarks together. There's three types of hadrons, which are things that are composed of quarks. Excuse me, there's a baryon, which is 3, which is our more common one. There's a meson, which is 2. And the last one is a pentahedron, which I have no experience with a pentahedron. But for quarks, for baryons, we're adding 3 together. Now our two most common baryons are protons and neutrons. And it's important that you know how to construct a proton and a neutron. Okay? So in order to construct a proton and a neutron, I'm going to get, for a neutron, I'm going to end up with 0 charge. And for a proton, I'm going to end up with 1 charge. So looking at this, if I had an up, an up plus an up, I'm going to end up with a 1 spin. Okay? And I'm going to end up with 4/3 charge. Okay? So from there, I want to be able to go and, wait a minute, I did something wrong. I do believe I did something wrong in my previous things. No, I'm fine. So what I want to do is I want to drop it by 1/3, and I'm going to use my first generation charges. My first generation charges are responsible for protons and neutrons. So if I had an up, and I had a down, if I had those 3 together, I'm going to end up with 4/3 minus 1/3, which is going to give me 1 charge, 1 unit of charge. Okay, which is a proton. It has 1 unit of charge. And I'm going to end up with a spin that's 3/2. Okay? So right there gives me my proton. So up, down gives me a proton. Now if I wanted to make an anti-proton, I'm going to go anti-up plus anti-up plus anti-down. That's going to give me a negative 1 charge. And a negative 3/2 spin. Okay? Cool? Now, that means that this particle is an anti of this particle. So I'm composing it out of anti-ups and anti-ups. And anti just means these properties are going to be flipped. So it's a negative 1/2, negative 2/3, negative 1/2, positive 1/3. Okay, so when I'm doing this, I'm going to end up with negative 4/3 plus 1/3, giving me a negative 1 charge. So that's an anti-proton. All we're doing is taking the exact same quarks and adding the antis of these together instead of adding the originals. Now, when we're doing that, another thing to keep track of when building quarks is color. So we're talking about flavor, and that's my types of quarks. The other thing we got to keep track of is color. Now, every single flavor of quark can have up to 6 colors, okay? And the 6 colors that we're talking about are the primaries: red, blue, yellow, and the anti-primaries: anti-red, anti-blue, anti-yellow. So when I'm adding up, down to get myself a proton, I'm adding a red up to a blue up to yellow down to get myself a proton. Or I'm going to put yellow, red, blue. It doesn't really matter the order of the color, as long as all 3 colors are represented in this particle. Okay? So it could be blue, yellow, red. It doesn't matter. It's just that all 3 colors are represented, because if you add red, blue, and yellow together, you get white. You get a white light. What we're looking for is prime color, or not prime color, but all colors. It's a particle. Now, when dealing with antiparticles, I'm adding anti-red, anti-blue, and anti-yellow together with my anti-up, my anti-down, and my anti-up again. So I'm left with negative red, negative blue, negative yellow with my anti-up, anti-up, anti-down. Same kind of configuration. Now, the really cool thing is, because of that construction, with anti-colors and colors and anti-quarks and quarks, when these 2 quarks combine, when they meet each other, that's matter meeting anti. That's when we get the annihilation of those quarks, and we release a whole bunch of photons. Okay? So that's what matter and anti is. It's just a configuration of quarks. Cool? So that was a proton. How about a neutron or other fundamental particle? So a neutron has 0 charges. I'm dealing with my particle up here, my first generation. It should be up, down, down. 2/3 plus a negative 1/3 plus a negative 1/3 is going to give me 0. So if we're looking at up, down, down, we're ending up with 0 charge. And a spin of 3 halves. Okay? And then the equivalent of that, the anti-equivalent of that, is negative up, negative down, red, blue, yellow, negative red, negative blue, negative yellow for the anti-particle. Okay? So that's the way in which I construct a proton and a neutron. Okay? So when you're building a proton and you have it, you're looking at a graph of spin versus charge, you're adding 1/3 and 2/3 together. You're adding a positive 2/3, which is up here, to a 1/3 down here, and you're adding this particle to that particle, 2 of these to 1 of those, to get myself a proton, and then 2 of these to 1 of these to get myself a neutron. Okay? So that's how you make them, in a sense, I guess. Something, you just don't go out there and grab so many quarks and glue them together and keep the particle. It's not that easy, but that's how those are created. That's how a proton and a neutron are created. That's how our hadron is created. Okay? Does that make sense? So up, down is going to give me my charge. It's going to give me my proton. And if I were to look at a graph of spin or charge versus spin, then you're looking at a proton is going to be a 1 and a 3/2 spin. So it's going to be like way over here. Where these other ones, I can get all sorts of different configurations to find myself all over. Okay? Cool? Proton, neutron.